Here is where we begin the realm of empirical formulas to molecular formulas. Since we know that the empirical formula is the lowest ratio, then the actual molecule would weigh more. The actual molar mass will be greater by a whole number factor. So it's either 2 times greater, or 3 times greater, or 4 times greater, or 5 times greater, etc. Whole numbers. To find that whole number, this is what you're going to do. You will divide the actual molar mass by the empirical formula mass. So let's say that you had your actual sample that you started with in the lab. You decomposed it so you were able to get percentages in empirical formula, but you wanted to know what was the real mass. What is that ratio to the true molar mass? So, caffeine in our last example has a molar mass of 194. What is its true molecular formula if our empirical formula that we just calculated has a mass of 97 grams? So how do we do that? This is how we're going to solve it. Remember that the factor is going to be a whole number. So by what factor are the empirical formula and true molecular formula different? Well, we said that we were going to divide the molar mass by the empirical mass, formula mass. And when you do that, you should get 2. Plug it in. Don't just watch the video and write it down. Make sure that you are actively getting these numbers as well on your calculators. Well, if our formula is off by a factor of 2, what that means is that we need to multiply each of these subscripts by 2. So our true formula is that right there. That is the true formula. All right, so let's do the last problem to practice, and then you are going to be on your own. Oh, look, I had that right there. I'll set up for you. And then you're going to be free to do your homework. So pause the video, work this out, and check your answer. All right, let's check our work. So we assume a 100-gram sample so that we can set these up as grams, and these should all be grams. That kind of annoys me. These should all be grams, 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 so that when we put these in our table, the grams cancel. And make sure that you are canceling the grams in your work, whoops, so that you are left with the unit of moles. Go ahead and pause it if you haven't finished this step yet. Then let's move on. What do we do next? We divide all of the numbers by the smallest number, which looks like it's 2.02 if we rounded to the hundredths place from the periodic table. And that will give us this molar ratio right here, this molar ratio, which if you add it up together, gives you an empirical weight of 48.5 grams per mole. See what that is to the hundredths place, because we really, when we're calculating from the periodic table those masses, we should be going to the hundredths place. Okay, so what are we missing now? This is the empirical formula. They told us that the molar mass is 98.96. So use your 98.96 and your empirical weight of 48.5. Figure out what your true molecular formula is. Pause the video, do that, and then check your answer. What you should have, once you've done the work, is a factor of 2. They should be off by a factor of 2, which means that the formula should be twice as much as we saw with the empirical. So you multiply all your subscripts by 2, and that is your final answer. So you are now ready to do your homework.